class. Today we're going to be doing section 4.3, which is properties of logarithms for our college algebra course. So we're going to start by looking at a few properties. The first property is the product rule. So first, b is our base of our log. It can be any real positive number except for 1. P can be any real number, and m and n have to be positive real numbers. So the product rule, log base b of m times n, we can separate this into log base b of m plus log base b of n. Now, logs, if you notice, if you remember from my previous lesson, a log is an exponent. So a lot of these properties are going to be similar to our exponential rules. For example, let's see, note exponential rules. We have x to the n plus m. Oh, I'm sorry. Here, let's do x to the n times x to the m equals x to the n plus m. So we add exponents if we're multiplying with the same base. It's a really similar to this log property. It's actually kind of a little inversed. Exponents and logs are inverses of each other, but multiplication within the log means if I separate them, I'm going to add the logs together. Similarly, the log base b of m divided by m would be the log base b of m minus the log base b of n. So another thing to remember, the log is the exponent, and a negative exponent makes something in the denominator. So if you have the log of and then a fraction, anything in the denominator, that's going to become a negative log. You can also think about it if I have x to the n divided by x to the m, I have x to the n minus m, so it's similar to that exponential property that we have. The power rule, log base b of m to the p power, is going to end up being p times the log base b of m. So I can pull that exponent out in front. This is really useful if we're solving in a log equation and we are solving for the exponent. We can bring that exponent out in front and then get rid of the log. Again, this is similar to this rule. When I have x to the n to the m power, I end up multiplying the exponents. So here the p gets multiplied to the log. The log is the exponent. So there's a lot of connections here. All right, and then the change of base property, this is super, super useful for when we need to put logs in our calculators that have bases that aren't 10 or e. So log base, I'm going to make it c of m divided by log base c of b. Or you can just think about it as log of m divided by log of b with a base of 10. So we can use our log button in our calculator. You could do ln of, here, let me show you. You could even do ln of m divided by ln of b with a base of e. So it doesn't matter what the base is. When you use this, it just allows you to find the log in your calculator a little easier. All right, so let's use these rules to write a single logarithm as the sum or difference of multiple logarithms, and we say that we are expanding the log. So I'm going to do a few of these examples. You can always write it down on your paper and try a couple. I'll give you all the answers, but I'll just kind of deeply explain a few of them. So the first one, we're going to use that basic property log base 4 of, and expanding it. If it's multiplication, we're going to add the two logs together. Pretty much, you know, your log is expanded as much as possible if the argument of the log, so the part inside the parentheses there, and you don't have to see parentheses, but that part of the log, if it's just one singular term. If it's one singular term, then your logs are expanded far enough. Part B, we have the ln of e plus the ln of x. Now this actually can simplify. So the ln of e equals 1. So sometimes we can simplify these a little bit more than just simply expanding the logs. So I get 1 plus the ln of x, but I want to see both of those steps so I can see your thought process. All right, so our second property, log base 7 of 19 minus log base 7 of x. So anything in the denominator ends up as the negative log. This one we're going to do in two separate steps. So we have the ln of e to the third minus the ln of 7. So using our property, our second property that we learned, which is the quotient rule, we get this here. Now, unfortunately, e to the third is not a single term. It's e times e times e. So there's three things in there. We need to fix that too. So I'm going to bring that exponent out in front. 3 times the ln of e minus the ln of 7. And then I can simplify this a little bit. The ln of e is 1 again. So 3 times 1 minus the ln of 7, which is 3 minus the ln of 7. So lots of things I can do with this one. You know what? It looks like I'm probably going to be doing each one of these. So part E, and you can always pause the video if you'd like. One thing to note is that the square root of x is the same as the x to the 1/2 power. So one of our exponential rules we've learned before. So this is the same as the log base 8 of x to the 1/2. We're going to use our power rule and bring that 1/2 in front of our log. So part F, we're combining a few of these rules. We have log base b of x squared plus log base b of the square root of y. And then I'm going to use my power rule, bring the 2 in front of the log base b of x, plus the 1/2 for the y to the 1/2 power because of the square root, times the log base b of y. And this last one is really cool. We've got log base 6 of x, the cubed root of x, minus, and now this part gets a little tricky, log base 6 of 36, and then I need to separate that one from the y to the 4th. And a lot of my students look at this and they're like, well, they're being multiplied, so you add. But the thing is, they are being multiplied, but they're grouped together. So if I add the log base 6 of y to the 4th, I need to group these together because they're both in the denominator. I'm subtracting the whole thing because they're both in the denominator. That negative gets factored in, and both of those terms become negative. So I'm going to change this to a negative. Now, another way to think about it is anything that's in the denominator is going to end up as a negative log. Remember, a log is an exponent, and a negative exponent ends up in the denominator. And so if I have stuff in the denominator, each one of those pieces is going to have a negative in front of the log. So that's kind of how I like to think about it. Now I'm going to use my exponent power rule. So if I have the nth root of x, that's the same as x to the 1 over n power. So this is 1/3 log base 6 of x minus, now log base 6 of 36, remember the log is the exponent. So 6 to the what power is 36? It's 2. So the log base 6 of 36 is 2 minus 4 times the log base 6 of y. So lots of cool things in that example there for you. All right, on the next page, we're going to go backwards. So we are going to condense the logs. So to condense a logarithmic expression, we write the sum or difference of multiple logs as a single logarithmic expression using our properties. So our goal is to find the log base 4 of something, the log of something, the ln of something. So each one of these, log of something, log base b of something, ln of something. So that's kind of our goal for each one of these, is to have just a single log, nothing in front of the log, not multiple logs, and just everything else inside the argument of that log. So if it's being added together, we're going to multiply the two pieces inside here. I can simplify this. So log base 4 of 64, which ends up being 3. 4 to the 3rd power is 64. Here I have the log of 4x minus 3 divided by x because the logs are being subtracted. And I can't really simplify that, so I'm just going to leave it like that. All right, and then we have, let's see, this power gets brought up to the x. So remember, that becomes an x squared, and then times x plus 1. And I can simplify this if I want. I can make this x cubed plus x squared by multiplying that x squared into both pieces. Again, I'm going to bring this power up in front, this power up in front here. So I'm going to have x to the 1/2 power times x minus 1 to the 4th power. Now, I do not expect you to multiply out x to the x minus 1 to the 4th power. I don't think that's going to make it simpler by any means. But what I would like to see you do is change this to the square root of x just to reinforce that property that the square root is a 1/2 exponent. I guess it wouldn't be required, but it's nice. All right, and then this one, we have a bunch of exponents to deal with. So bringing that number out in front of the log up to be the exponent of the argument. And then we have two negatives in here. So we're going to have two things in the denominator of our log. So we have x to the 4th in the numerator. And then I have a 6 squared times a y to the 1/2 power. So remember, yeah, they're both being subtracted, but that just means that they are both being in the denominator. So you can think about it as negative and then 2 log base b of 6 plus 1/2 log base b of y if you want to just distribute that negative out or factor it out. And that shows that those two pieces are being multiplied together. I'm going to clean this up a little bit. Log base b of x to the 4th divided by 36 times the square root of y. Just looks a little bit nicer. All right, and then the last one here, we have x plus 7 cubed and then divided by x, and I'm going to leave it just like that. All right, last piece here, the change of base property, log base b of m is the log base c of m divided by log base c of b, or we can write this as the log of m divided by the log of b, or the ln of m divided by the ln of b. So we can use any log we want. That's why I put c there. We can use any base we want. I usually use a base of 10. And this is really, really useful for evaluating our logs. So log base 5 of 40 would be log of 40 divided by log of 5. And then you can plug that in your calculator by just simply using the log button, log of 40 divided by log of 5, and you should get 2.292-ish. Again, log, and you know what, let's just, for funsies, I want you to type in your calculator, what happens if I use the ln of 40 divided by the ln of 5? I want you to see that it's the same. So type in ln of 40 divided by ln of 5, natural log, and I still get 2.292. So it's the same regardless of if I use a base of 10 or a base of e. All right, and then try this one on your own. Log of 2506 divided by log of 7, you should end up with log of 2506. Don't forget to close your parentheses after you put the log of 2506 and then put parentheses divided by log of 7. I get 4.022. All right, and that's it for today's lesson.